Good morning, guys. This is already Wednesday here, January 20th. Here's the deal. We're going to talk about minerals. And as we say here, minerals are the building blocks of rocks. I know we have a bunch of rocks, but actually there's a bunch of different minerals in rocks. And I know minerals might not be what exactly we're used to, but you probably come in contact with minerals way more than you think. Now, there are some specific things you need to remember that make a mineral a mineral. But first, let me go back to this. I know we said minerals are in rocks. In fact, they make up rocks. A bunch of different minerals can make up rocks. Maybe think of it like a school. We have one school, right? But you guys know a school is made up of a lot of different parts, right? We have kindergartners, we have first grade, we have third grade, we have eighth grade, we have the teachers, we have the pastors, we have other different things. So there's a lot of things that make up one school, right? If you really look into it, there's all kinds of different things that make up one school. Well, same with rocks. And again, I know we might not have been so interested in rocks, but I bet you, whether it be a Peridot rock or some other rock, there's a reason you pick up a rock and you think, man, that's got some pretty little parts to it. And whether it's shiny or whatever, those are the minerals that make up the rocks. If you really pick up a rock, yep, some are bored and some are just a piece of limestone or something like that. But some of them are made up of a lot of different parts. Those are the minerals in the rocks. And minerals are a lot of different things that you might not realize. In fact, just like you see this lady doing, minerals are in your toothpaste. It's amazing, but it's true. They actually found some different things that help clean teeth. We're going to talk a little bit more about that. Not say toothpaste, but the Mohs hardness scale. We're going to talk about a little bit more tomorrow and different things like that. But even more than just toothpaste, all these different things are now, please don't think that you can go and pick nails out of the ground. Oh, hey, look, I found a huge thing of nails. No. This is from the iron ore that they find in the ground that they can melt and turn into nails or different things made out of steel. Okay, so that's what we're talking about. Same with this. You don't just find a pipe in the ground, but you find copper in the ground. And where do they find copper? Down in the rocks. The steel that you use, the lead in the pencils are happening all the time. Now, please understand we're going to be looking at a lot of different things, but these are all different minerals that you use. Now, this is the average American in your life is going to use 30,000 pounds of salt. Salt is a mineral. It's naturally made. That is natural to the world, and you put it on your French fries and you go to McDonald's, and basically everything that comes in a can or almost all foods have some kind of salt in. Look at it: stone, sand, gravel, petroleum. We use you dig up in the ground, you melt it, and we get petroleum. That's used for cars and oil, iron ore, different steel and iron, lead, all these different things. In your life, you're going to probably use 3.75 million pounds of minerals, metals, and fuels in your lifetime. All those little things in the rocks, those are the minerals. Now, what is a mineral, you ask? I know this is a big, long, huge word, but we're going to take this slowly but surely. It's a naturally occurring inorganic solid with a definite chemical composition and a particular crystalline structure. What? Here's the thing. There are lots of different minerals, and they're all made up of different things, how God made. Now, let's go back to like we talked about yesterday, something we're very common with, like water, right? If you have your water bottle, your water jug, this is a liquid. Believe it or not, water is made up of two different things, hydrogen and oxygen. Sometimes if you hear H2O, Well, now we're talking about chemistry and stuff and how things are made, but there's actually 2 hydrogen and 1 oxygen atoms in here that make up water. That's why different fish and sharks and things like that can actually breathe underwater, because it still has oxygen. Not enough for us and fish with gills and things. They can indeed breathe oxygen in water. That's what I mean when I talk about the crystalline structure, especially definite chemical composition. They're made up of different chemicals and different things that make it a solid. Now, what I mean by naturally occurring is that man did not make this. Man did not do this. This is an exact picture we found from yesterday. This is metamorphic rock, and people did not do this. Yes, people can dig it, and this is that nice hard granite that they found that you can use and cut and make for buildings, but people didn't make this rock. People didn't make the minerals. Inorganic and natural simply means that this is a natural process in nature that man cannot duplicate and do. This is all God's doing. It has never been alive. You guys know that rocks are non-living. But remember what we talked about yesterday, that intense heat and that intense pressure and that rapid melting and coming out of the volcano as lava and then cooling down to a solid rock. That's an incredible amount of heat and pressure and change that's happening with these rocks, and that can actually change the chemical compound, meaning it can actually change what's in it. All this stuff that we mine, people cannot make. You cannot go to a factory and make limestone. You cannot make gold. In fact, if you learn more and more about history, there was a lot of different scientists, and I'm talking like hundreds of years ago, that devoted their lives to trying to make gold in a factory or in, some science lab. And guess what? They never did it. Why? Because gold is a mineral, and gold happens naturally. People cannot just make gold. That's why I have a picture here of sugar. Now you take a look at a little sugar grain inside a microscope and stuff. It looks a lot like a mineral. It's not. Sugar comes from the plant called sugarcane, and you guys know that plants are indeed alive. They're made up of cells, and they grow, and that's where we get sugar. Sugar is not a mineral. Sugar is something we get from a plant. Gold and different rocks indeed are minerals and rocks. And so the same goes with this amber substance. That's like a sap type substance that you might have on trees. Well, that comes from something that's alive. So that is not a mineral. Again, amber, sugars, they might look like minerals. They might look neat and kind of like almost a diamond or gold type thing. Not minerals. They come from things that are alive. Rocks, minerals, they were never alive and don't come from things that are alive. And yes, even things that are not alive can change. Just like we talked about rocks. Now, again, this is what I mean by the chemical composition that is made up of certain chemicals and things like that. Just like water is made up of hydrogen and oxygen. Sorry to keep going through here, but minerals now, again, you might know that minerals and gems are used for diamonds or bling or crowns, and they're beautiful. They're beautiful, but they're all found in the ground. And some of them are found, all of them are make up rocks, but what people have found out over the years is if they heat up rocks so much, it can melt it, and then you can divide the different minerals that we want. Get rid of the garbage rock part and keep the minerals that we want, and all of a sudden we're left with just the gold, or we're left with just the copper, because all these minerals that make up a rock melt at different temperatures. So you have a big giant rock that they find in the mines, and it's got a bunch of copper. You can heat that up so much that the rock literally melts, turns into magma, but the copper doesn't melt. Now, it's incredibly hot, but it's still not melted yet. And so you get rid of all the garbage rock, and you have copper left over. you cool it, and all you have left is copper. Now, certain gems and crystals, again, went through these different things. You find these in rocks. If you ever seen, a diamond mine, it's in the rocks themselves. A lot of work has to be taken out to get the diamonds and the gold and the copper out of the rocks, and a lot of that is done through melting and things like that. But something we're going to learn, especially tomorrow, is that how can you tell the differences between different minerals? Pyrite and gold are both minerals, but they are very different. You guys might have heard of different stories about gold rushes. You had Alaska gold rush. You had a California gold rush. In fact, if you like football, the San Francisco 49ers, why in the world are they called the 49ers? Why are their colors red and gold? Well, in 1849, gold was discovered in California, a little earlier, but in 1849, huge groups of people, I'm talking hundreds of thousands of people, traveled to California just to look for gold. And you know what? A lot of people found pyrite. And they said, I'm rich, I found this mineral. I got the rocks off and I got this big mass of pyrite. But they didn't call it pyrite, they called it gold. And you can understand there's some similarities, isn't there? However, there are ways to tell the difference. One way is color. Now, if you came and brought your whole family from a state out east, out of California, and looked for gold, and you found this, you'd probably be pretty excited to think you found gold. You'd be disappointed to understand that it's pyrite. And here's how you can tell the difference. One is something we call luster. That simply means, does it look kind of dull like this? Or does it look like metallic-y or glassy? It actually has a little bit of a shine to it. That's the stuff we want, right? The shiny stuff. Well, again, this is pyrite, and pyrite and gold both have the same... Pyrite and gold, let me go back here, sorry. Pyrite and gold have both the same color, and they both have the same luster. They both are glassy, they both are gold, and so one of the only ways, two ways are the next things. One is called a streak. Now please notice, this is gold, this is pyrite. They leave a different streak. When you literally take it and put it across a piece of paper, they lose different colors. This with the greenish black streak, not good. That's pyrite, and pyrite is a mineral, but it is worthless. Nobody wants pyrite. Gold is going to leave a nice yellow streak. So that's how people would tell. If you bring it into the bank or the store, they literally take it and say, okay, I just need to make sure this is pyrite or gold because they look the same. They have the same color. They have the same luster. They have the same, glassiness look. I need to do the streak. And so they'd put a streak, and if it's gold or yellowish streak, hey man, we're paying some big bucks for you. If it's greenish black, sorry, take this pyrite. I don't want it. Nobody wants it. Another thing that they can tell the difference is between what they call the cleavage or fracture in the rock world. Simply put, you guys might know that some rocks are kind of, roundish and things like that, and some rocks crack it. It's almost like glass. Well, if it has this kind of smooth, glassy surface, that's a type of cleavage. Or if it fractures into different rough, jagged, almost like a glass-like fracture, that you can tell the different minerals by that. Some rocks, like you take a bunch of sandstone, you just take it, just breaks apart and falls into all, a bunch of different pieces. That doesn't have good cleavage or good fracture. This type of halite or mica, I think is how I'm saying it right, that would have the cleavage. It would have the nice smooth flat surface, and it has a fracture that it would almost break like glass if you had something hard enough to actually break it. So that's a way you can tell it. Yes, another way is by smell. If you've ever smelled sulfur, it has that rotten egg smell, and you can tell sulfur without even looking at the color or luster or fracture. Some of it, like halite, actually has a salty taste. Don't taste it because there's actually a lot of minerals that are poisonous. And some people, if you're big with rocks, some are actually magnetic. So you take a magnet to it and it has, it sticks to the magnet. They can tell what kind of mineral it is. A lot of them are difficult because just like the gold and the pyrite, they look a lot alike. They have the same color, they have the same texture, they have the same luster. Remember, luster is the how it looks, glassy or dull like this, and things like that. So that can be what difficult, but there are different ways to tell minerals apart. Some minerals we use all the time. You would be surprised at how much copper is inside the walls in your house and buildings. Gold is actually in a lot of different computers and things like that. And yes, it can also be used as currency or money. But there's also a lot of minerals that we really don't have much of a use for. Pyrite might look really cool, not expensive, not really used for anything. So, at any rate, I hope we learned a little bit more about minerals. We're going to really talk about this tomorrow. And, where is it? The Mohs hardness scale. This is another way to tell the difference between different minerals. And yes, spoiler alert, the diamond is the hardest mineral that we know of. Incredible. Incredible. This is what we're going to talk about tomorrow. Today, there is no assignment. Your assignment was to watch the video. Tomorrow and Friday, there will be assignments. And again, tomorrow we're going to talk more about this Mohs hardness scale of minerals. Hope you guys have a wonderful day. Lord's blessings to you as you praise your Savior.